Your bunker door opens outward. You installed it that way because it made sense. Push it open from the inside, step out, pull it closed behind you. Simple, functional, and completely wrong. Because the first time someone on the outside wants in and you don't, they're going to force that door. They'll pry it, they'll ram it, they'll use leverage. And because the door opens outward, every bit of force they apply is working with the hinges, not against them. The door frame takes the stress, the hinges take the stress, and eventually something gives. You reinforced it, added locks, made it heavy steel, but you built it backward. You made a vault door that opens the wrong way. In a siege, in a home invasion, your door is helping them. Let's look at why. When a door opens outward, the hinges are on the outside, the frame stops are on the outside. Everything structural is accessible to an attacker. They can pop the hinge pins, lift the door right off, and walk in. Your $1,000,000 lock is now irrelevant. They can wedge a crowbar between the door and the frame and apply leverage. The gap widens, the metal bends. The door fails at its weakest point, usually the lock or the hinges. Or they can just ram it. Each impact transfers force directly to the mounting points. Metal fatigues, bolts shear, the door comes off. You can keep reinforcing it, but you're just fighting physics. The fundamental problem remains. Force applied from the outside is working with the door's opening direction. Meanwhile, submarine hatches have been solving this exact problem for over a century. They're built to withstand pressure differentials that would crush your bunker door like a soda can. They seal tighter the harder you push on them from the outside. They're physically impossible to force open from the wrong side. And the principle is so simple, you could retrofit your bunker door in an afternoon. Here's the secret. A submarine hatch is a plug. It's designed to be slightly larger than the opening itself. The hatch sits in a recessed frame. From inside the sub, you pull the hatch into the opening. It plugs the hole. Then you dog it down. Dogging is the key. These are lever arms or a big wheel that operates cams, pulling the hatch tight against a seal. The more you dog it, the tighter it seals. Now here's the brilliant part. Water pressure from the outside pushes on the hatch, but because the hatch is larger than the hole, the pressure just pushes it deeper into the seal. The harder the pressure, the tighter it seals. This is a pressure-actuated seal. External force can't open the hatch, it only helps to close it. At a depth of just 100 meters, a 1-meter hatch has over 140,000 pounds of force, pushing it closed. The deeper you go, the tighter it seals. Now apply this to your bunker. You don't have water pressure, but you have the same design principle. Make the door a plug that seals from the inside. Make external force work against the attacker, not for them. Here's how you build it. The door is slightly larger than the opening, maybe half an inch all around. The opening has a recessed frame. The door sits in this recess when closed. Around the inside edge of that frame, you install a rubber gasket. The door itself has dogging mechanisms on the interior side. Simple rotating cam latches are perfect. To close the door, you push it into the opening from inside. It plugs the hole. Then you dog it down. The cams engage and pull the door flush against the seal. It's now locked and airtight. From the outside, what does an attacker see? A flat surface, flush with the wall, no hinges, no exposed hardware, no lock cylinder to pick. If they try to force it, they're pushing the door deeper into its seal. They're helping you. The door can't move outward because it's larger than the opening. It physically cannot pass through. If they try to pry it, the pry bar has nothing to grab. The door is flush. They'd have to cut a hole in the wall first, which defeats the point of attacking the door. Or they can just ram it. Each impact transfers force directly to the mounting points. Metal fatigues, bolts shear, the door comes off. You can keep reinforcing it, but you're just fighting physics. The fundamental problem remains. Force applied from the outside is working with the door's opening direction. Compare the two. A conventional outward opening door, even a good one, can be forced with sustained effort using basic tools. Time to breach, minutes to hours. A plug door sealed from the inside can't be forced without destroying the frame or the wall. Time to breach, same difficulty as breaching the wall itself. You've turned the weakest point of your shelter into its strongest. It's the same principle used by medieval castles. Their main gates were thick wooden doors that seated into a stone frame and opened inward. Attackers couldn't pry them. They had to destroy them completely. So look at your bunker door. It's strong, it's locked, and it opens outward. You can leave it and hope no one ever tests it. or you can spend a weekend rebuilding it as a plug door that seals from inside. What you gain is a door that becomes stronger under attack, a door that turns an attacker's force against them, a door that can't be forced, can't be pried, can't be bypassed. The next time someone tries to force their way in, they'll discover they're pushing on a plug that only gets tighter the harder they push. They're not breaking in, they're sealing you in better. That's not paranoia, that's engineering. That's physics working for you instead of against you.